Hi friends, in this video we solve problems related to maximum power transfer theorem. Let us see the first question. Find the value of RL, that is R subscript L, such that the power transfer to RL is maximum. Right? So what they ask, we want to find the value of this resistance RL such that the power transfer to this resistance must be maximum. So we have to use maximum power transfer theorem. Right? So whenever you want to find the maximum power transfer theorem, the condition is the maximum power transfer theorem states that the maximum power transfer to load when load resistance is equal to source resistance. That load resistance must be equal to Thevenin resistance, right? Okay, the equivalent resistance must be Thevenin resistance. That we have to find. So what we have to find in order to find value of RL, we have to find Thevenin resistance. Let us find the Thevenin resistance for this circuit. So to find Thevenin resistance, what we have to do, all the sources must be removed. Voltage source must be shorted and the current source must be open circuit. So this must be shorted and this must be opened. So the circuit becomes like this, right? So this source is short, this source is short, and this is opened. Then I kept out. The load must be kept outside. Okay, so now the equivalent resistance must be Thevenin resistance, right? So what is the total resistance? R Thevenin is given by 10. These two are parallel, 10 and 10 are parallel, and which is in series with another 10. So 10, 10 parallel, two equal resistance parallel means total resistance will be half of that. So 5, so it is plus 15 ohm. So the answer for RL is, so when RL is equal to 15 ohm, the maximum power is transferred from source to load. That is the answer. Okay. Second question, a source of angular frequency 1 radian per second has a source impedance consisting of one resistance in series with one inductance. So Z is equal to R plus J XL. So 1 plus J, inductance is 1. So this is what my source. The load that will obtain maximum power. So whenever we have a complex source impedance, the maximum power is transferred to the load when ZL is equal to ZS dash. So what is the value ZS dash? That is 1 minus J, which is nothing but resistance in series with capacitance, because negative minus sign indicates it is capacitance. So this is not omega, it is ohm, right? Ohm, 1 ohm, right? So 1 ohm resistance in series with 1 farad. You see, R is equal to 1. See, this is 1. So C is equal to 1. So option C is the right answer. Next one, the value of R, that is this resistance, required for maximum power transfer in the network. So like that, like we did for problem number 1, we have to find the equivalent resistance. First, how can we find? Short the source, voltage source, right? Open the current source. This one is opened. Remaining here is 4, and this is kept as reference. This R is kept as reference. So 4 ohm, 5 ohm, 20 ohm. Now you see this 5 and 20 are parallel and it is in series with the 4 ohm. So 5 parallel 20, that must be in series with the 4. So 5 into 20 divided by 5 plus 20 plus 4, 100 by 25, 4 plus 4 is 8. So it is 8 ohm. So the answer is 8 ohm, right? Okay. Next question. You see the source is given. Your source Vs of t is given by V cos 100 by t as impedance Zs. Source impedance is 4 plus J3 ohm. Fine. If a purely resistive load is connected to this source, To extract maximum power, what is the resistance value? So it is RL, it is pure resistor, it is not ZL, it is RL. So what must be the value of RL? So the condition is if the source impedance is equal to source resistance in complex impedance, then if pure resistive load is connected, then RL must be equal to root of R Thevenin square plus X Thevenin square. Here R Thevenin is this one, so RTH, this is X in reactance. So 4 square plus 3 square, that is equal to 5. So that is the answer. So 5 ohm, if pure resistance is connected, is pure impedance is connected means it must be 4 minus J3, right? So that's what our problem number 3 says. Right now it is purely resistive network is connected. So it must be load resistance must be equal to root of R square plus XTH square. And the next one is the maximum power that can be transferred to a load RL from the voltage source in figure. So for maximum power transfer, load resistance must be equal to source resistance. Then only maximum power will be transferred. So this indicates RL must be 100, right? So RL is 100, right? Power transfer is P is equal to V squared divided by R, RL, right? So what is V? You see total voltage is 10. So it is divided among these two. So both are same resistance. So this must absorb 5 volt, this must absorb 5 volt. So V square is 5 into 5 divided by RL is 100. That is equal to 0.25 watts, right? So the answer is 0.25 watts. Next one, in the network of the figure, maximum power is delivered to load if the value. So I have to find the maximum power delivered to the load here, power through this load. But you see the question, we have independent source, right? So whenever we have dependent source, we can find only R Thevenin. We cannot find V Thevenin. So for maximum power transfer theorem, we have to find V and R. So V Thevenin we cannot find because it is dependent source. So in this problem, how can we find R Thevenin? R Thevenin is equal to V Thevenin by ISC. So I short circuit. So first, we can find R Thevenin is equal to V Thevenin by ISC. In this method only we can find, right? So how can we find? You see that first we find V Thevenin. Right, in order to find that, I have to discard this. So I redraw the diagram. Find 0.5 I1. This will be like this. This will be here only. We have to find V Thevenin. So this will be V Thevenin node. Find this is 40 ohm. This is 50 volt plus minus. Here current flows is I1. Right, this is 20 ohm. Fine. So from this you can see this current is coming here, right? And okay, just apply KCL at node V Thevenin. Apply KCL. So incoming current is 0.5 I1. This is incoming current. Outgoing current is given by, you see this is this is the V Thevenin. So I take this is the V Thevenin. Both are same only V Thevenin. So incoming is 0.5 I1. V Thevenin, this node is V Thevenin by 20. For this branch, current flowing is V Thevenin by 20. For this branch, the current flowing through that is I1. Right? So what is the thing? If you simplify, it will give 10 I1 is equal to V Thevenin plus 20 I1. This implies V Thevenin plus 10 I1 is equal to 0. Okay, from this we can see this I1. From this branch we can say I1 is equal to V Thevenin. Use here to here. V Thevenin minus 50 by 40. So this thing, substitute this here. V Thevenin plus V Thevenin minus 50 by 4, because 10 divided by 40, 1 by 4, that is equal to 0. This implies Thevenin is equal to 10 volt, right, if we simplify. Similarly, we have to find I short circuit, ISC, right? If you want to find ISC, what we have to do, let me draw the diagram. So the circuit will be like this. Here it is short, right? So ISC, and here this is 40, this is 50 plus minus, here I1 goes. This is 0.5 I1, right? Yes, 0.5 I1. So how can we find? This is 20 ohm. Yes, yes, of course it must be 20 ohm. Fine. So you see ISC, this is what current flowing through this short, this is what ISC. So here what is incoming current? Incoming current is 0.51. In 0.51, I1 is going this branch, so 0.51 minus I1 is equal to ISC. Right? So out of 0.5, I1 goes here, so remaining thing is ISC. This implies ISC is equal to minus 0.5 I1. Right? So what is I1 here? I1 is given by, the voltage is V, R is 40, so it is 1.25. But you see, when current flows from here to here, then only it is plus 1.25. But this current goes in the opposite, so it must be minus 1.25. So I1 we got minus 1.25. This implies IS is equal to, substitute I1 here, then ISC is given by what is it, 0.625. So we got ISC and Thevenin. So R Thevenin is equal to 10 divided by 0.625. That is nothing but 16 ohm, that is equal to R load. So the answer is 16 ohm. Right? Okay, the next question is, what is that? You see, a source of V cos pi 100 pi t as an internal impedance. I think we have done this already. So answer is, they have asked in EC also, IEEE also. So 5 ohm. Okay. Next one, the value of R, the value of this resistance R required to transfer maximum power to the load. This is what load, right? So for maximum power transfer theorem, we know after simplification, we will get this with this is R, this is RL, right? R must be equal to RL. So I want to find RL, which must be equal to this one. So right, let me do that. So first I minimize this. How I'm going to do? P is equal to power delivered to the load is I squared into RL, right? Okay. So what is the load here? This equivalent distance is 6 into R divided by 6 plus R, right? These two are parallel. So 6 into R divided by 6 plus R. So I squared R. What is the current flowing through the circuit? Right? I is nothing but V is by 10 by R. R is nothing but what you call R Thevenin plus RL. Right? That is what V by R is nothing but I into R. Right? This is what the condition. Okay. So from this you will understand the maximum power is delivered. Maximum power is delivered to the load if R Thevenin is this, right? R Thevenin should be minimum. For maximum power transfer, R Thevenin should be minimum, because R Thevenin minimum means power will be maximum. Denominator minimum, this power will be maximum. So R Thevenin should be minimum, right? What is our R Thevenin? R is equal to R. This is what our R Thevenin. right? So what is that? 6r divided by 6 plus r must be equal to 0. This must indicate r is equal to 0. Fine. So the answer is 0. Right? So we know for maximum power transfer, R Thevenin is equal to RL. These two must be same. Right? So this must be equal to 0 for minimum. Right? So R must be minimum to have R Thevenin minimum. Minimum value is 0. So we get it. Okay. The next question is, under maximum power transfer condition, power absorbed by the load RL. Right? So they ask maximum power. So I need current and all, right? So first what I need, I have to find power. P is equal to I squared RL, right? So I squared RL I have to find. I squared is nothing but Vth squared, sorry, Vth by Rth plus RL, right? So Vth by R plus RL, that's what we have to find. Square into RL. This is what this one, right? Okay, let us find all the things. I is nothing but Vth by Rth in maximum power transfer theorem. Okay, right. So first we find Thevenin. How to find Thevenin? Whenever you want to find Thevenin, just make it open. Here only we have to find Thevenin, right? Okay, this is what Thevenin. Here we have to find Thevenin, right? Apply KCL. You see for this branch, right? This is what Thevenin. So Vth minus 110, 0. You see for this branch I am applying. Vth minus 110, 0 divided by 6 plus G8. Next I find Vth for this branch. Vth minus 90, 0 divided by 6 plus J8. I use KCL, nodal analysis. That will be equal to 0. Right? So if you simplify, what you get is Thevenin will be equal to 100, 0 volt. This is what Thevenin. Next, what we have to find, R Thevenin we have to find. In order to find R Thevenin, what we have to do? We have to remove all the source. We have to keep only the resistance. Remove the load also. So this will be, what is that? This one like this. This is like this, this is like this. It will be like this. I removed source, I discarded load 6J8, 6J8. So these two are parallel. 6 plus J8 and 6 plus J8 are parallel. So ZTH is equal to 6 plus J8 parallel with 6 plus J8. So if two equal resistance are parallel, two resistance are equal, then and parallel, they are their equal distance is off. So 3 plus J4 ohm. Right? So ZTH we found. What we need is RL. RL, right? So what must be RL? RL, see for the second problem we know when input impedance is complex, RL must be square root of these two, right? ZT. This is what ZS. So Z Thevenin equal resistance 3 plus J4. I have to find the magnitude. So 3 square plus 4 square, that is 5. If load is purely complex, sorry, real, right? Resistive. So now we got everything, RL, everything. So P is equal to Thevenin. Thevenin is 100. We got Z Thevenin 3 plus J4 plus RL5. This square, I squared into RL5. If you simplify, what you get is 625 watts. This is magnitude, right? Magnitude. That's what I have written. So 100 divided by 3 plus J4 plus 5 squared is equal to I squared into R. 625 watts. So the answer is option D. 625 watts. Right, so that's all about this session. I hope you understand everything. If you have any doubt, please ask me in the comment section. Thank you.